All right, everybody's favorite part of math, applications. Woo woo. These really are my favorite things. I always found it enjoyable to solve a problem instead of just calculate this and do this over this and divide by this number and square this and do this, and to actually get in application problems to me seemed fun. It was nice to play. Anyways, so solving these problems, this is always my first step. I've always taught it from pre-algebra to pre-calculus to statistics. Anytime you do a story problem, you should read through it. Read through it all the way until you start recognizing certain things. And you're looking for math words, right? So keep that as kind of a note. Look for math words. And there's tons of them, right? There's money words. There's something as simple as the word is sometimes. But as you go through, that's what you're going to do is read, and identify some things. So this is our first example. It's a nice simple one, good way to get started. It says a coin box contains $26.50. Okay, that's a dollar amount, that's money, that's math, in dimes and quarters. Okay, we got some money going on. It says there are 157, so there's another number, coins all together. Now it doesn't seem like a math word, but that's actually a math word. That means total. Then the question says, how many of each type are there? Now, this last sentence in story problems is usually the most important one, right? How many of each type are there? So how many tells you you're looking for the number of something. Each type, and then you have to say, what do you mean type? What are my types? Well, that goes back up here to these other math words. I hate all my arrows and how they go forever around the book, whatever. Then you want to start with identifying what each variable represents. And this last sentence is usually how you do that. So I'm going to start with x. X is going to be the number of, doesn't matter, you get to pick, let's say dimes. And I'm going to let y equal the number of quarters. All right, now it gives us two sentences. It talks about their values, right? $26.50. And then it says 157 coins altogether or total. Well, if X is the number of dimes and Y is the number of quarters, then the number of dimes plus the number of quarters has to be equal to 157 coins. That's what that second sentence right there says. So usually a sentence makes one equation. Usually, I'm not going to say always. Usually you can read through and like that second sentence helped us form an equation. The first sentence is going to help us form an equation, but it's not like cut and dry. Like here, 5x plus 2x, you've got to actually put some pieces together. Okay, so let's talk about that one. The value, the total value is $26.50. So the question I always start with students when I'm teaching this, I say, okay, what if I had 5 dimes? How much money is that? And everybody will go 50 cents. And I ask you, how do you know? How do you know that if I have 5 dimes, I have 50 cents? And some of them just go, because that's 50 cents. But the answer is each dime is worth 10 cents. So if I had 8 dimes, that would be 8 times 10 cents or 80 cents. So the formula for the value, right? This is a value. I'll run out of room if I write too big. So we're going to go 10 cents, 0.10, times the number of dimes, plus, now we're talking about quarters for y, which is 25 cents each, times the number of y. So value, let's see, dimes equal 10 cents, quarters equal 25 cents. Okay, now we have a system. You can choose at this point, if you want to get rid of those decimals, you can. You guys know how to get rid of decimals, but you don't have to because we're solving using matrices now, and you can put decimals. You can put decimals into a matrix. It doesn't matter. All right, let's form our augmented matrix. We've got 1, 1, 157. We've got 0.1. I'm going to drop that 0. It's not necessary. 0.25 and 26.5. Then we plug it into our calculator, and we're going to get out our REF. Now you guys can do it on matrix.desmos.com. I have a calculator closer to me, so I'm just going to do this. 2 by 3. I should pause it during this point, so I would save the time on the video. Sorry. All right, so what I get is this for my augmented matrix. Which means x equals 85 and y equals 72. Now, those were just our variables that we used to figure out the actual problem. So our final answer would be that there were 85 dimes and 72 quarters. Ka-ching! Quarters. 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 72. Now, what if you weren't quite sure? You thought maybe calculator had a little problem, right? You could check by looking at the values. You could say, okay, wait, 85 dimes, that's $8.50. And then 72 quarters, that's $18. I did that in my head. Are you proud? Impressed, I mean. I get $26. Excuse me, $26.50. So check, that's the correct answer. So that's the best part about matrices is now all you got to do is get the system set up. Once you have the system, you're ready to go, boop, 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 calculator says or Desmos says or whatever. It's just setting up that takes the thought. But they're all kind of basically the same, these simple steps. 1, 2, 3, 4, 2. 1 is not so bad reading. It's 2 and 3 that take the practice. 1 and 4, not too bad. Let's try another one. A plane can travel 6,000 kilometers between Washington, D.C. and London in 6 hours with the wind. Travel 6,000 kilometers in 6 hours. Now, this becomes important, and we'll talk about why. On the return trip going against the wind, the trip takes 7.5 hours. Find the rate, that's a math word, in still air. We'll talk about that in a minute. Let W equal the wind current. Okay, these are D equals RT problems. They are one of the most widely used it is one of the most applicable places for systems. D equals RT is huge. So setting it up, you notice it says that they're traveling from Washington to London, and then they return, they go the same way. So Washington is one way to London, and then London to Washington. Now, what we're going to do is set up equations that have to do with D equals a rate times the time. Now, the tricky part about these, oops, that's R, is this whole with the wind and against the wind type thing. So you're flying an airplane, right? You're cruising right along. This is, you know, what do we want to call him? Giovanni. He's got one of those oh, but he can't be Italian. He's got blonde hair. Anyways, so he's flying along, and if it's with the wind, then that wind has come along, right? And it's pushing him and making him go faster. So this would make him go faster. But when he's going back the other way, oh, here comes the wind. It's pushing against him, and it's actually going to slow him down. So that's what the wind has to do in thing. That's why they mention the wind with the wind and against the wind. Sorry, I lost my train of thoughts. Okay, so let's identify the pieces and where they go. It says 6,000 kilometers between Washington and London. Now, obviously, that's a distance. So that's got to go right here. Now, from Washington to London is 6,000 kilometers. That means from the return trip, London to Washington is going to be 6,000 as well. Okay, let's talk about the other pieces. We're also told that it takes 6 hours. Well, that's a time. So I'm going to put 6 here. And then it says the return trip, it takes 7.5 hours. So we have almost got our equations. We just need a rate. So there's two pieces to this. There's the actual rate of the plane. That's our variable. R equals the rate of the plane. I almost just spelled it P-L-A-I-N. And then we've got this other variable, W, that's going to be the wind current. That's how fast the wind is going. All right, so whatever his rate is, we have to have two variables. We have an X and a Y. We've got to have two different variables. If it was one, it would be too easy. So we've got these two variables, R and W. Rate is how fast the plane's going. So that's obviously R right here. And then when he's going with the wind, that means the wind is increasing his speed, how much ever W is. Now when he's going against the wind, here's his rate, but the wind is pushing him and slowing him down, so it's actually reducing how fast he's going. And that's your two equations right there. Now, of course, we got to put parentheses right here around these. This is your rate, time, and distance. So our two equations look like this. I'm going to write the variables on the left. I don't like it when it's on the right. 6 times R plus W equals 6,000. Then you've got 7.5 times R minus W equals 6,000. Now before you can set up, found it. Before you can set up your augmented matrix, you have to distribute. So 6R plus 6W equals 6,000. And then 7.5R minus 7.5W equals 6,000. Okay, augmented matrix, here we come. 6, 6, 6,000, 7.5, negative 7.5, and 6,000. Okay, coming out, we're going to see what we get for an augmented matrix. You guys will get quicker at this. Okay, so that's what I got for my augmented matrix, which means we've got R, this was our R, this was our W, so R equals 900, and then W equals 100. And it asks for, find the rate of the plane in still air. So the rate of the plane equals 900 kilometers, it says right here, kilometers per hour. Okay, those are two variables. Now, a couple of things I want to make sure you notice. This is two variables, and we had two equations out of it. Two variables, two equations. So usually, and I know you hate it when I use that word, but I can't tell you all the time because it doesn't happen all the time. Usually, the number of variables equals the number of equations. It's possible to solve a system with 3 variables with just 2 equations and vice versa, but I don't think we'll get into those in these examples. Just, that's why I throw the word usually in there. Okay, let's try harder ones.